Okay, so we've got a few more coming in, but we'll make a start as we go through. So this is our monthly CPD for wastewater heat recovery for residential new builds. So I'm going to go through an overview of wastewater heat recovery, how it works, some of the products that we have in the portfolio, how they differ from one another, the scenarios that they're used for, and then a look at Part L regulation and a look towards future home standard and what we know there. An element of designing in wastewater heat recovery and the impact in Part L, just a kind of a designing case study and some impact there. I do have some case studies on apartments as well, which I can go over if we have enough time, and then hopefully a brief case study on some net zero, and then some time for Q&A. At sort of the end of each section, I will pause just to see if there are any questions. And just so you know, my colleagues Craig and Chris are both in the background. So if you want to put questions into the chat, they can answer them as you go along. But generally that works quite well, and we'll sort of summarise with questions at the end of each section. So we'll move through. So who uses wastewater heat recovery? Well, in the UK at the moment, it's mainly used by new build developers, predominantly for new build housing, as a method of achieving Part L compliance. So our main product is the vertical pipe system, which we'll look at in some detail as we go. But we do also have products as well as suitable for houses, for ground floor showers, for apartments, for bungalows, passive houses, whatever else there may be. So essentially anywhere where there are showers, we have a wastewater heat recovery system that should work. So we'll go through those as we go along. So house builders are really probably 90% of the market at the moment in the UK, but that's expanding. Certainly seeing much more interest from hotels and student accommodation new build, as well as the Part L changes for residential new build, which have come into force this year. The same transition and changes have occurred for non-residential. So again, a big uplift there, slight similar carbon reduction. So certainly non-residential is an area where we're seeing much more growth as well. And then, as you would expect, anywhere where there's showers with high shower traffic environments, so sports, leisure centres, swimming pool changing rooms, that sort of thing. Again, wastewater heat recovery can make a really good impact there. And then looking forward, we're certainly starting to see retrofit, social housing decarbonisation fund, these sort of areas of social housing refurb where wastewater heat recovery is becoming more important and something that people are more interested in there. This CPD is mainly geared up towards residential new build, but if anybody wants to talk about domestic or non-residential, I'm more than happy to stay on afterwards and discuss. I've got a few other case studies towards the back of the presentation which we can look at. So why use wastewater heat recovery? Well, it's a simple heat exchanger technology, and it's used just to reduce the amount of energy demand for hot water when showering. So it really is quite a simple technology, but it can offer significant energy and CO2 reductions, especially for new build, but essentially anywhere where there's showers present. And it requires very little adaptations to incorporate wastewater heat recovery into most new builds, and we'll look at that as we go through. But the reality is most new build developers, and certainly the larger volume developers, sort of top 20 that we're engaged with, use this for Part L compliance, because it really is a simple and very cost-effective way of achieving SAP points. And obviously there's a minimum Part L compliance that's required. So in a way, cheaper SAP points are better in this respect. However, despite it being a good box ticker for SAP, it does have a good impact for in terms of hot water reduction. So we'll take a look in a moment at an example, but our vertical pipe product installed to a standard sort of new build ensuite, we would expect that to probably reduce the energy requirements per shower by about 55%. So it really is quite significant. And from an end user point of view, there's no changes in end user showering experience. There's no sort of filters or consumables, and the units can't be switched off. They're always on, they're instantaneous, they're essentially part of the plumbing infrastructure. So very easy to design in, and we'll look at that as we go forwards. Essentially a fit and forget product with a long lifespan, essentially around about 40 to 60 years attributed to the vertical pipe systems, and currently around about 25-year working lifespan attributed to the horizontal systems. And then finally, if anybody has their eye on embodied carbon, we're a very low embodied carbon product, and again we can look at that in a little bit more detail with a couple of slides towards the end. So Recoup have a range of wastewater heat recovery products, but the one that we will focus on initially is the vertical pipe system, and I'm just going to sort of show you what that looks like and essentially how wastewater heat recovery works with quick animation here. So it's important to say at the outset, currently wastewater heat recovery as a SAP listed technology requires a thermostatic shower mixer to work. So it won't score SAP points with electric showers. We don't recommend currently that wastewater heat recovery is used with electric showers. So currently it's for thermostatic mixer showers only. The reason for that is that when you shower with a thermostatic mixer, your comfortable or desired temperature, shower temperature coming out the shower head at a fixed flow rate is maintained by the TMV mixer, adjusting the ratios of hot to cold in the background, so that if there's any changes in either the cold temperature, the hot temperature, or pressure coming in, the TMV will adjust that and maintain that fixed flow and desired temperature. So normally when you shower with sort of hot water around about 55, 60 degrees and incoming cold about 10 or 12 degrees, your mix of hot and cold is around about 70% hot water and about 30% cold water. That would give a sort of 40, 41 degree desired temperature coming out of the shower head. And then usually when you're showering, about 85 to 90% of that heat energy is lost down the drain and usually just leaves the building. So this is where wastewater heat recovery comes in. So with wastewater heat recovery, it's a heat exchanger that is fixed to or in between the shower waste and the SVP. And then what you can do is you see here that warm shower waste goes down one side of the heat exchanger, so falls through the heat exchanger pipe, and then the grey water goes off to the SVP. At the same time, when you turn the shower on, cold water main is drawn through, goes around the outside of the wastewater heat recovery pipe, and then or the heat exchanger, and comes out preheated. So what we're doing is we're preheating the incoming cold and getting a free energy uplift from that outgoing waste that would normally be, or waste heat that would normally be wasted. So if we've got sort of a 10, 12 degree incoming cold feed, we'd probably expect around about 25 to 28 degree preheated water. So it's a free issue uplift of sort of 15, 18 degrees. And that's the basics of wastewater heat recovery. All products all work in that same way. So warm waste goes down one side of the exchanger, preheated water is generated on the other side of the exchanger. However, there are 3 SAP listed installation methods, and sometimes the terminology gets a little confusing, but they're relatively simple. So the most efficient method of installation is where we send the preheat, as you can see here, to both the cold side of the shower mixer and back to the hot water source, whatever that may be. So by sending preheated water to the cold side of the TMV, what will happen is the TMV will now adjust the ratio of hot to cold in favour of more of the free issue cold side and less generated hot water. So that 70-30 ratio that we started out with 70% hot water will almost go opposite to about a 60-40, 70-30 mix of cold to hot. So you're immediately using much less hot water per shower. And then by also sending preheated water to the hot water source, so whether that be a combi boiler, cylinder, air source heat pump unit, heat interface unit, whatever that may be, by sending preheated water to, for example, in this case, the cylinder now doesn't have to heat up from 10 degrees up to 60. It's heating from about 25, 28 up to 60. So you're using less hot water per shower on one side, and the hot water you are using is produced more efficiently on the other side. So that's system A, that's the most efficient, and that's generally what we would expect to see on your primary shower in any standard new build. So master ensuite, pipe hex, system A, that's normally going to give the biggest bang for your buck. Now, if you were to have more wastewater heat recovery units into a domestic scenario. So let's say you've got second showers, third showers, and you need an extra wastewater heat recovery unit. That will then need to be installed as System B. And System B quite simply sends that preheated water just to the cold side of the shower only. So this is completely isolated from the hot water system. And obviously, relatively, it's a simpler installation because everything is localized around that shower. So System B, by just sending preheat to the cold side of the shower, just adjusts the ratio of hot to cold. We're going to sort of use about 44–45% less hot water in this instance. So whilst it's the lowest efficiency installation method, it's still quite significant. And then just for completeness, as you might imagine, System C sends the preheated water just to the hot water source only. So this is a bit more scenario specific. If you imagine perhaps you've got a townhouse where you've got second floor showers over the top of a first floor shower. For the sake of less pipe work and incorporating two showers into one wastewater heat recovery, you could feed the waste from both showers down onto the pipe on the ground floor and then install a System C where you're just feeding the preheat back to the hot water source, which is probably a combi or a boiler that's maybe on the ground floor or the first floor. So System C is a bit more scenario based, but can be used, sits in the middle in terms of efficiency and can be used to reduce installation pipe work and essentially installation cost as well. So just to summarise, as with any heat exchanger, the slower the flow across the exchanger, the higher the efficiency. And this is seen in standard shower flow rates. Sorry, I'm a little bit in the way there. Sort of standard flow rates of 11 and 9 litres per minute. You can see here that the overall system efficiency of the wastewater heat recovery unit increases as you drop down. And then in terms of an energy demand reduction as System A, we'd expect somewhere around about sort of 54 up to about 58% at those typical shower flow rates. At lower flow rates, we'd expect a higher demand reduction because, as I said, it's more efficient. These data are taken from the PCDB, which is the database for UK SAP, where SAP draws its database from. It's worth mentioning at this point, all of our products are third-party tested by Kiwa, which is a European test house. So Kiwa do the third-party testing and validation. They send the data to BRE. BRE crunch the numbers and put it into the PCDB, which is used for SAP scores and EPC scores and things. That's the same for all products that are on the PCDB database. So anything that's on the database needs to be third-party tested and validated. And then just on that System B efficiency, as I said earlier, again, sort of typical shower flow rates, 9 litres per minute. We'd expect a hot water demand reduction in this case, because it's just on the cold side, of around sort of 44 to 47%. So again, really quite significant. It's also worth mentioning as well, if anybody's more on the retrofit side than the new build side, System B, as you can imagine, is generally the simplest method of installation for retrofit as well. So if you're retrofitting, generally just taking a cold feed that would normally be feeding the cold side of the shower, or a thermostatic mixer over bath, that would be dropped down into a wastewater heat recovery unit and then back up again. I'll show you some examples of some of the more retrofittable products that we have as we go through as well. So I'll just stop there. Just Craig, Chris, any questions on how that works? And then I'll go into a bit more on the product detail itself.
Nothing in the chat.
Okay, let's move on. So as I said, we have a full range of products. The main one we'll look at initially is the vertical pipe system. This really is our bread and butter bread and butter product for new build. Ideal for new build because it gives it a high efficiency, generally low installed cost, and is suitable for standard house types where you've got showers on first floor and above. So in most cases, when you have showers on first floor, generally they're located relatively close to an SVP. And so the wastewater heat recovery unit will normally box in next to the SVP. As you can see here, the waste from the shower is just gravity fed into the top of the wastewater heat recovery unit. The waste connections can either be in the ceiling void or in the SVP boxing, depending on your connections and things, ceiling heights and stuff. But the product's designed to fit within the standard 2.4 metre ceiling void, so it's designed for standard new build. Our product gets its higher efficiencies because we have a very long wastewater heat recovery heat exchanger. We use all copper construction, and the turbo rotator, which is at the top here, our waste connection, does a good job in ensuring that the waste clings to the inside of the vertical heat exchanger pipe. So just a quick example of that on a video here, which isn't clicking through for some reason. What is that then? Okay, there was a very nice example on the video. Ah, there we go. Okay, coming through now, a little bit of lag. So this is just a cut through of the turbo rotator, and you can see that warm waste coming through, or what would be warm waste coming through. This is simulating 9 litres per minute. So the waste comes through, it's directed to spin by the turbo rotator, and then the effect of that, as you can see on the pipe here, so this is simulating the internals of the pipe, is that that waste forms and clings to the inside of the pipe. So we get what's called thin film heat exchange, maximising surface contact, maximising that energy transfer into the exchanger. And then from there, as described, cold water main is going to come in through the bottom, and then around the outside of the copper heat exchanger, between the PVC and the outer, the cold water flows and then comes out preheated. So this is just an example of the unit and the installation components that come with it. So we supply the pipe and the installation kit with mounting brackets and things. All that's normally needed in addition to the components we supply is a double check valve and 2 full flow isolation valves, one top, one bottom. That is all that's required for essentially for installation compliance on wastewater heat recovery. So it really is very, very simple. Obviously from here you could run off with system A, system B, system C as specified. Just a word on the construction of the wastewater heat recovery unit. It isn't quite as simple as a pipe in pipe as might be imagined. We use a double walled, mechanically pulled sort of pipe in pipe construction, and then this double walled exchanger sits within a PVC outer skin. The eagle-eyed amongst you will see that there are striations within the pipe here. These run the entire length of the exchanger and are open at top and bottom. What this does, it means that we have then a built-in leak detection system, which means we can directly comply with EN 1717 for potable water regulations. In practice, it means that if there was ever a perforation within the exchanger at first fix or first test, when mains pressure switched on, there would be a visible leak out the bottom of the unit. So it's that visible leak detection that ensures we're compliant. I will caveat that with every product is pressure tested to 6 bar before it leaves the factory gate, and to date, in 10 or 12 years of supplying into the UK, we've never had an issue with a perforation. But it's a belts and braces approach to compliance for potable and grey water mixing. What it means from an installation point of view, and there are a couple of products in the UK that still use a single walled construction, is that if you install with a single walled unit, you need to move the shower trap or the bath trap from where it belongs underneath the shower or bath to downstream of the wastewater heat recovery unit for that compliance. So obviously that then potentially adds installation height, perhaps falling water noise, and also sort of accessibility issues and things. You don't really want your shower or bath trap on the ground floor or the floor below the shower. So all of our products are double walled, all comply with EN 1717. So the shower trap stays where it belongs, doing the heavy lifting in front of the wastewater heat recovery unit. So I mentioned about sort of the design changes required in terms of incorporating wastewater heat recovery. Generally, SVP boxing is sort of 220 by 220 mil or so. With wastewater heat recovery, it really is just another 200 plus or so mil in one direction. So it really doesn't take up a great deal of floor space at all. Usually wastewater heat recovery will connect directly to a shower directly above. Of course, showers over baths, perfectly acceptable as well, as long as they're thermostatic mixer showers, but equally they can be designed in to take the bath waste, shower waste, as long as they are suitably close to one another, and we can kind of talk to you about this, or as I mentioned, sort of stacked showers or back-to-back bathrooms, that sort of thing. So there's quite a lot of flexibility in the design, and if you sort of Engage with us if you've got floor plans, if you're looking at wastewater heat recovery for either group house types or developments. Send your plans across, we can have a look at them and just ensure that you're getting the most cost-effective design. So, you know, rather than maybe using 2 wastewater heat recovery units for individual showers and baths, we might be able to advise that you can combine those and things. So it's really worth engaging with us. The team here can turn these around pretty quickly and get sort of suggested designs back to you. And then finally, the vertical pipe product, our pipe hex, is the only product that all of the national merchants stock and sell centrally. So in terms of supply chain availability, available from, I think, around about sort of 3,000 branches across the UK next day. So it dovetails into existing developer and installation design chain, supply chains. And then finally, just a couple of notes on installation and operation. Wastewater heat recovery, a first fix installed product. So certainly for new builds installed at first fix, generally an extra 1 to 2 hours of plumber's time. So it really isn't a particularly expensive product to install. Only basic materials, tools and knowledge required. So there's no specialist training, no MCS accreditation or anything along those lines. Because there are no moving parts, no electrical connections, no filters, no consumables, no serviceable elements within, it's just a heat exchanger for all intents and purposes. There's no planned maintenance required. So the same routine cleaning, routine maintenance that you would do with a shower without wastewater heat recovery is exactly as you do with wastewater heat recovery. And in most cases, your end user, your customer, your homeowner just simply won't know it's there. It boxes in. There's no changes to the showering experience. We're not looking for them to reduce flow rates. It's exactly the same showering experience as with wastewater heat recovery as without. And it works every time the shower's switched on. You can't isolate it, you can't switch it off, and there's no filters or anything to block up. So it works every time. So that's the vertical pipe system. It's gravity fed, and that's why it needs to locate on the floor below the shower it connects to. So it's great for standard house types where you've got showers on first floor and above, but for anything else, we then have a range of horizontal or active products. So here we're looking at the Easy Fit. This is a standalone wastewater heat recovery unit designed to fit directly under a bath. So that unused void space under the bath, this is designed to just sit in there. It will connect obviously to the thermostatic mixer shower above. So thermostatic mixer shower over the bath, again, can connect system A, B or C. It all works in exactly the same way. By design, not quite as efficient as the vertical system, so about 2/3 the efficiency. However, where these are used in apartment new builds, the way that SAP calculates hot water usage in apartments is slightly different from houses. So the horizontal system can score almost as well as the vertical system does in houses as it would do in apartments. So it really is still very good bang for your buck. Can be installed also under suitably sized riser tray. So we have designs or schematics showing this designed from anything from about 14 by 800 riser tray upwards. So it's a reasonably big tray, but if apartment en suites generally a 1400 by 800 will work in a lot of cases. So it does have some flexibility, can be used there. As I said, good SAP score for apartments. Again, the method of operation is pretty much the same here. It does have a bit more flexibility. So warm waste goes in one side, comes out the other side. Cold main goes in the opposite side, so we're getting counterflow heat exchange, but equally the unit can be rotated around 180 degrees. It doesn't matter which side the waste comes in or goes out, as long as the cold feed comes in the opposite direction. In this case, the exchanger is actually a flat serpentine exchanger, so almost like a flat coil, if you like, designed so that we have lots and lots of exchanger length in here. And then what happens is when the warm waste goes through, that literally floods out across the pan of the unit. And then at standard sort of shower flow rates, 9, 11 litres per minute, even down to sort of 5 and 6 litres per minute, that shower weight, the grey water is then designed to mix over and under the repeated coils of the exchanger. So we're getting lots of mixing, lots of turbulation, and that's how we get this sort of high efficiency in a vertical system, in a horizontal system. However, the exchanger is about 2 millimetres above the pan of the unit. So at the end of use, when the shower grey water just finishes, the whole unit is designed to just run clear. So any debris that might have got past the shower trap, so maybe some hair or something that gets through, that's just designed to flow through at the end of use. The unit itself, I don't think I've got a, yeah, maybe this shows it here. We have adjustable legs, so you can adjust the fall on either side. And so at the end of use, that simply just flows through and off to the SVP. So really good system. This product's been in the market now for coming up for 6 years, used in social housing, used in apartments, used in new build, on ground floor showers, bungalows, that sort of thing. So that's the Easy Fit. The Easy Fit, as I said, is really good, I mean, especially for apartments where your primary shower is normally a shower over bath. But there is a trend, certainly in apartments, but also for DDA bathrooms, for ground floor bathrooms and things, for level access showers. So the Easy Fit isn't particularly ideal for that. As with any device, and wastewater heat recovery is a device, so despite being planned maintenance free, we still would deem it needing reasonable access, and different specifiers have different thoughts on reasonable access. But from a Recoup point of view, we suggest that the Easy Fit, for example, isn't boxed in underneath, or isn't concreted in underneath shower trays, or located under trays in floor voids and things. So for that reason, we've introduced the Pipe Hex Active. So what this is, as you can see here, is a pumped upgrade kit for our existing vertical pipes. So it means that we're now leveraging that high efficiency that we get with the vertical pipe, but by having a pumped upgrade kit with it, it allows the pipe to be installed on the same floor as the shower it connects to. So we'll try and sort of show that a little bit of detail here. So exactly the same pipe unit, so that the Pipe Hex, or the Pipe Hex RD, which is a smaller unit that we have. And now instead of the turbo rotator, we have what's called a turbo buffer. So this is essentially a buffer cylinder, holds about 1.2, 1.3 litres of water, with a turbo rotator within it. And so once the buffer's filled, the whole system is working exactly the same as it would do under gravity. The turbo rotator is just dropping water through the unit and down at the same time cold water feed comes up preheated. However, with this system, we've teamed up with Saniflow, with one of their, or in fact a pair of their Saniflow off-the-shelf grey water lift pumps. Saniflow have been in the grey water lifting market for a lot of years in the UK, so great products, great pedigree, great servicing. And so now when you shower, that warm waste will drop down flow down under gravity into the pump. The pump has an activation limit of about 1.2 litres. So as soon as that hits 1.2 litres, so literally seconds when you're having a shower, that will then pump up at high velocity up into the buffer cylinder, and then that will start dropping down. So now what we've got is a system where we're pumping up and over. The pump activates intermittently, so it pumps at high flow, and then that drops through under gravity. What this means for the pump system is that it's only active for about a third of the time that the shower is being used. So where we have a nominal 250 watt pump here, on a 9 litre per minute shower, for example, we're using around about 85 watts nominally as an average across the shower use. So it's a very low energy method of pumping up and over onto a wastewater heat recovery unit. But as I said, it now allows that high efficiency pipe to be used on the same floor as the showers it connects to. So this is just an example of the unit we've got in the demo area here. Sorry, I thought I had another slide there. But yeah, connects in basically the same way. Obviously, with a pump system being introduced, we are now introducing a mechanical and electrical component. So when designing this in, some consideration needs to be for where the pump unit is located. This does need to be accessible because there are servicing recommendations with the pump. I think Saniflow recommend that sort of serviced every sort of 2 or 3 years, I think it is. So it does need to be accessible. So arguably there is a compromise here. However, for those more problematic showers where wastewater heat recovery is still required, this is a potential solution. So you know, it's a mechanical element, but it does have high efficiency. So it's something that can work in certain scenarios. And then just to complete the range, we also have a range of wastewater heat recovery integrated wet room drain channels. So these work in the same way as a standard linear wet room drain, sort of recessed drain channel. However, as you can see here, all of the wastewater heat recovery element is located within the drain body. So this is the Drain Plus version, and this is the Drain Plus Duo version. Duo because we have both a brushed stainless steel cover and a tile-in cover. But as you can see here, works in the same basic way. Warm waste is going to drop in this case onto a percolation plate. You can see here these holes are strategically placed so that they will line up. This plate would obviously slide across. They will line up with the exchanger. That again allows us that thin film waste drop onto the exchanger, so we're maximising surface contact. And then simply the drain water drops onto the coils and then drops into the body of the unit and will flow off. So there's a drain trap at the bottom, a shower trap at the bottom there. So these units there's 3 in the portfolio currently. Varying efficiencies from about 35 up to 57%, so really quite efficient on the high end, but they will require differing depth of installation. So they're the same basic size, but anywhere between top of my head 120 down to about 160 millimeter depth required for recessing these. Not used too often in residential, in fairness, but certainly for non-resi, for leisure centres, for communal changing rooms, showers, these are phenomenal. Whenever you've got high shower traffic, these can ROI in sort of 1 to 3 years in a lot of cases. So they really are a really good product for non-residential. But also, you know, if you've got high-end wet rooms, tiled wet room floors, DDA floors, these could be an option there as well. I'll pause there. That's as much as we're going to do on products and how things work, and then we'll look at some compliance and designing in. Any questions, Craig?
Nothing in the chat, no.
Okay, anybody at all? Got any questions at this point? You've all been muted, so you probably can't, I guess, can you? Okay, well, I'll move on, then we'll open up the mic at the end. So why is wastewater heat recovery important? Well, hot water traditionally was certainly a much smaller component of kind of the energy use in a UK home. So we've got here a pie chart showing sort of typical data from a sort of 20, 30 year old 3-bed home. This is from the Energy Saving Trust a few years ago. And generally, thank you. So generally, space heating demand has always been the biggest part of the energy use in the home. Sort of 2/3 would be a fair average for sort of a 3-bed home or sort of 20, 30-year-old home, with water heating being anywhere sort of 18 to 23%. Showering, certainly in most modern homes, is at least 50% of the generated hot water. So, you know, if you're generating a 200 litre tank of water, around about 50% of that at least is going to be going on showering. In apartments, it tends to be more by comparison. So anywhere sort of 70 to 80% would be fairly common in terms of the amount of generated hot water used in apartments. So it really is a big user of energy, showering, and certainly a big part of the hot water budget. And as I said, of that hot water that comes out the shower head, that's very hot water that's being tempered down by cold, so it's already inefficient, and then that's coming out the shower head, and about 85–90% of that heat energy is then going off down the drain as waste. And essentially it's a big thermal bridge. It's just being lost from the home. So when we look at that and we take those sort of percentages on percentages, we might expect an average home, sort of non-new build, to look at sort of space heating of around about sort of 60–65%, hot water about 23%. If 50% of that hot water use is showering and 85% is going down the drain, that's potentially about 10% of that home's energy budget going down the drain and being lost. So it's really quite important. And then as you look at homes becoming much more efficient in terms of space heating demand, so increased fabric, increased air tightness, and reduced space heating demand. So we're looking here at a sort of an average 3-bed home modelled under Part L regs, so current regulation. The expectation is space heating demand is lower, so sort of 47%. Hot water demand in relative terms would be more, so about 34%. And then so that amount of energy that's being wasted from that home's energy budget is relatively increased. So even if we'd expect like for like showering in one home and another, but that relatively it's more wasted energy as we're going forward, because more demand is on the hot water side. That could look anything like sort of 5 to 10% of a home's energy use going down the drain. Obviously, if we move towards passive house, that becomes hot water. The hot water budget becomes even bigger, so it's more of a consideration as well. So just to kind of look at the direction of travel, this is a timeline that I've found off of Travis Perkins. Actually, it's quite a nice way to show the direction of travel for energy efficiency in the UK. Where we are currently, Part L 2021, a minus 31% carbon reduction. Previous regulation was 6%, so it's a big jump. The expectation will be around about 75–80% carbon reduction for Future Home Standard 2025. That's yet to be consulted on, but that should be coming out very shortly. But I think most developers are kind of understanding that around about a 75–80% reduction will be required. And then the expectation is that from 2030, there will likely be a net zero carbon regs as well being put forward. So this obviously hasn't been consulted on yet, but that's the expectation that from 2030, most new build will likely be required to be net zero. So that's the direction of travel on new build. For non-resi, this was a great slide up until a couple of weeks ago when Rishi Sunak made his announcement, but most certainly social rented housing association properties need to be up to EPC C. Most rented properties were expected to be up to EPCC going forwards, but that's currently been cancelled. But the expectation is that when we've got sort of around about 13+ million homes not at EPCC in the UK, some kind of guidance or regulation is going to have to come out to start moving those up. So the expectation is that whilst new build is at pace at the moment, retrofit of homes will be picking up a lot more pace going forwards, and certainly social housing decarbonisation fund and some of the funded drivers that are in place for both private and social rented is starting to push that. But really we're here to talk about Part L and new builds. So what are the key changes that kind of apply to wastewater heat recovery under Part L? So as I'm sure you're probably aware, Part L 2021 fully transitioned in June of this year. So now any home in England that's been built or gained planning permission or wasn't in the ground with significant foundations from the 15th of June will need to be built to new Part L regulations. Key changes, as I said, 31% reduction for residential, about 27% for non-resi. Notional dwelling fabric has been improved, and there is a fees element to this now, which is the same as previously, so minimum fabric requirements required. Boiler flow so essentially low flow boilers are now required, so essentially bigger radiators, lower flow, lower temperature gas boilers. PV is included in the baseline case. Whilst you can get through Part L without PV, it is realistically quite difficult. Air source heat pumps do have the potential to do that. And then wastewater heat recovery has been included in the notional dwelling as for the first time. So this is really where a lot of eyes are on wastewater heat recovery, despite it being a technology that's been in the market for sort of 10 or 12 years in the UK. It really is. This is the big catalyst for wastewater heat recovery use in new build now. So what we're seeing, certainly where around about sort of 80 to 90% of certainly the developers that we've engaged with seem to be looking at using gas boilers for Part L compliance going forwards. And that really, sorry, forward one. The expectation is that if you're using gas boilers, that wastewater heat recovery included as part of the infrastructure, and then PV, which gives then some flexibility on number of panels, is really probably the best and most cost-effective way of getting compliance with gas boilers. Obviously, air source heat pumps are available, and some developers are using air source heat pump. That has the ability to get through Part L very, very well. There are some issues with the EPC scoring currently, because obviously electric using being a more expensive per kilowatt. There are, I think, with EPC scores, it might not always get through with just an air source heat pump and fabric, so there are some tweaks to be made there. But it's worth knowing that wastewater heat recovery works very well with air source and any other hot water technology. But from a secondary benefit point of view, because you're not really necessarily looking for the SAP points with air source, but it helps to mitigate sort of seasonal changes. So with air source heat pumps, when they're trying to provide space heating demand in the winter and hot water demand throughout the year, they can sometimes struggle, or perhaps longer recharge times and things for cylinders during the heating season. So wastewater heat recovery, by reducing the hot water demand, can help sort of smooth out those edges and essentially just complement air source heat pump solutions very well. We're working with most of the major developers at the moment. So Recoup have really kind of been targeting top 10 developers. That's really where we exceed. We're kind of the most specified product in the UK currently with our pipe hex. But in terms of smaller developers and single builds and things, we can support you with developing, and certainly SAP assessors for smaller developers, we can support you as much as you need. So on that, in terms of designing in and SAP modelling, I think the thing to take away from this is it is a relatively simple product, certainly compared with a lot of other products designing in sort of energy efficiency products. In the main, a vertical pipe, so a pipe hex installed to a master ensuite as System A, is usually, probably 80% of the time for most houses, going to be the most cost-effective option. So really, pipe hex, System A, master ensuite, or if you can do it ensuite and bathroom next door, is the most cost-effective route. Certainly for apartments and for 2 or 3 bedroom homes, a single wastewater heat recovery is normally going to be the sweet spot in terms of efficiency, SAP points and cost. So it really shouldn't be too much more difficult in most cases. For anything else, do feel free to lean on us. If you've got bigger homes, maybe that require 2, 3 wastewater heat recovery units, we can take your floor plans, we can make suggestions, and we can come back to you with kind of a list of different options, or graphical options, design notes, all that sort of thing. Really being very explicit, so that either as a developer you can give this off to your SAP assessor, or as a SAP assessor you can model this and then forward it on to the developer and the installers, so everybody knows exactly what's going on, what's been installed where, and that way it reduces the potential for any break in spec and things like that, which obviously all of us want to avoid. If you can consider wastewater heat recovery as early as possible, and you have influence on sort of design and layout and things, it's certainly possible to feed the waste from 2 showers, so either back-to-back showers, stacked showers, showers and bathrooms, into a single unit. And again, we can advise on the sort of how to do that and the limitations on that in terms of design and flow rates and things. So again, feel free to lean on us on that. So just a quick sort of run through on a typical 3-bed. So this particular 3-bed, master ensuite, TMV shower, shower over bath, but in this case it's just a hand shower, so it doesn't count as a shower in terms of SAP score. So just a standard hand shower, so all intents and purposes is the bath. If this was the sort of thing we were looking to model, this is the type of thing we would come back with. So again, just a graphic representation of what we're looking to install, some design and installation notes here. Here's your specification, and then we're literally just showing wastewater heat recovery locates here and it connects to this one. So this kind of information can follow down the sort of design journey so that everybody understands exactly what's required. So as I said, in this case, we're kind of showing where it's all included. From there, as a SAP assessor, SAP 10 obviously has had some teething issues. I think in the main it's working quite well now. It's certainly working well for wastewater heat recovery. When you're modelling wastewater heat recovery in SAP, I think there are a few SAP assessors on the call today. You're looking at section 28, which is water heating, and literally you're going to click for, in this case we would click instantaneous wastewater heat recovery 1, because we're putting 1 wastewater heat recovery unit in. We're going to then choose the system. So either you can go through the list and pick, for instance, Recoup pipe hex and then System A, or on the notes that we send you, we'll always put the PCDB index number, so you can just plug the index number in here and then it will self-populate, which saves a lot of time, especially if you've got lots and lots to do. And then from there you would just need, in this case, just to click that there's one bath in place. And from there, this is the important part. Because SAP 10 is dynamic, sometimes when you're looking at it in a browser, you may see a view like this. You may see this section that you need to scroll down to at the bottom. So we've had some instances, some queries from SAP assessors where they're not seeing any impact in wastewater heat recovery. That's not possible. What's normally happened is they haven't seen this button to click here. So you click here, it brings up another window, and this is where you then connect that wastewater heat recovery unit you've just specified to the shower or showers that you've got on the unit, excuse me. So here we're going to enter your description of the shower, say that it's connected to a combi boiler, unvented hot water cylinder in this case. You can specify the flow rate, and then the important bit is you need to click to say that it's connected. So that shower that you enter the data for here, you then tick, and then that connects it to the wastewater heat recovery unit. You can connect, in this case, more than one shower, so you could add multiple showers in and connect them to a single wastewater heat recovery unit. You could obviously add a second wastewater heat recovery unit and become a bit more complex, but essentially it's as simple as that. So as a sort of trying to tie this all in together, then if we were to look at a SAP model, this is actually on part SAP 10.1, so this changed ever so slightly, but just as guidance. That 3-bedroom mid-terrace that we were looking at with a System A pipe hex installed to the ensuite, we're looking here at a primary energy difference, so a reduction of 10.7% and a CO2 reduction of 11%. So it really is quite significant in terms of its impact on sort of a standard 3-bed as it was there, or realistically a home with a single shower as this is. So yeah, it really is quite impactful. So in most cases, that's really the amount of information that developers and SAP assessors need. The win for wastewater heat recovery is those high SAP points, simple, low installation and low installed cost. And that's where it wins over other SAP listed measures in terms of getting Part L compliance. However, we can look at this as granular as you need to. So not necessarily for new build, but for non-resi projects, for housing associations, asset upgrades, that sort of thing, we can get really granular. So everything you're looking at here is based on that 3-bedroom, and we're using SAP defaults for showering. So 6 litres per minute, 9 litre per minute shower, etc., etc. So we can sort of, spit out the energy in kilowatts, either per day or per year saved. We can look at how that impacts on heat, hot water generation under different heat sources, so gas, LPG, direct electric or air source, and then we can look at sort of ROI, and we can also look at the carbon savings. So if you're looking at bigger projects, or realistically, if you just want to look at this and ensure that it's making savings, we can look at this with you and provide this kind of information for you. I did mention about embodied carbon, so I'll just draw your eyes to the annual carbon savings that we're getting here from a gas boiler and from an air source heat pump on that 3-bedroom home. So we're looking sort of 164 kilograms a year on gas saving, 131 on air source. Recoup were quite lucky to be involved with CIBSE on their TM65 creation of this TM65 standard for embodied carbon. So we were able to give them some manufacturing and product data and get early visibility and help them with the calculation methodology. So as you can see here, I won't go through this because I've realised we're quite low on time if we're going to get some questions. But essentially, we use a circular manufacturing process in our manufacturing. All of the electricity for the factories to produce the products are all from renewable energy, on-site renewables that are generating the energy to produce the products. The majority of the product, sort of I think about 82% by weight, is copper. And of that copper, around about 70% of that is recycled, and obviously it's 100% recyclable. So we have a highly recyclable product that's produced in a very sustainable way, and therefore we get a very low embodied carbon number. So if we just look at that in terms of how that compares to those annualized savings, you can see the CO2, the amount of CO2 required to produce the product is really, really low compared to the amount of CO2 that it can reduced per year in sort of standard domestic settings. So yeah, just to frame that, I think that's quite a nice way to frame it. If you're okay, I won't go through the apartments in any real detail, but needless to say, if you have an apartment with a shower over bath, the Easy Fit is probably your best option in the first instance from a cost efficiency point of view. If you then have ensuite showers, the Pipex Active can be an option. It's also worth mentioning at this point that we have other products that are in the pipeline as well, so keep an eye out for those coming through, specifically looking at apartment new build and retrofit. I just want to touch on just this case study very quickly, if we've got time yet. So Recoup have been in the market for sort of 12 plus years now, tens of thousands of units sold to new build developers in the UK. We've been sole supplier to Barratt since 2013. We're currently have framework agreements with a number of the biggest house builders in the UK who are all looking at using wastewater heat recovery as part of their standard spec. So where we are currently, and certainly looking at future homes, wastewater heat recovery seems to be firmly on the design case, I think would be fair to say. But looking forwards, I thought this was quite a nice case study from Barratt. So they've been looking at their net zero journey as a company, but also on their homes and producing net zero carbon homes. The ambition is to produce all net zero carbon homes by 2030 or before. And as such, they've already been looking at pilot schemes for this. So I won't dwell on this too much, but essentially everything that Barratt are looking at the moment seems to have wastewater heat recovery from previous regs all the way through to their pilot schemes. And two of the pilot schemes that have had a lot of press recently is the Z House that was completed about 18 months ago. And then more recently, they've got a version of this, a 3-bedroom home that's built in the Energy House up at the University of Salford. So this is essentially a great big warehouse, which is completely sealed, insulated, and can produce weather anywhere from -20 all the way up to +40. It can produce snow, it can produce wind, it can produce rain. It really is a fantastic place to go and have a visit. And there's a number of homes. There's a Barratt home in there, there's a Bellway home in there, there's a number of smaller developers that are building homes and doing testing there. So just to look at the Z House, which is a net zero pilot, so it's essentially a net zero now home that's built on a standard Barratt 3-bedroom blueprint. And this is really nice because what they've done here, they've incorporated a number of currently available and readily available sustainability, biodiversity and energy efficiency technologies into this 3-bedroom home as a test case. And within that is wastewater heat recovery, so nice and easily put in here, so connected to the bath and the shower above. Interesting, using on the ensuite a Kelder low flow powered shower. So this is running at around about 5.5 litres per minute. And then on the shower over bath, which is a formed thermostatic shower over bath, they've got a low flow, so it's just a traditional flow restriction to about 6 litres per minute as well. And then the wastewater heat recovery unit, the waste from those running to the wastewater heat recovery unit. So working very, very well on those low flow showers. In part, that the turbo rotator really helps us maintain efficiency with the low flow. That direction keeps the low flow rates clinging to the inside of the exchanger. And then this particular house is generated by air source, but it's also got solar, it's got battery storage, and it's a really good example of how wastewater heat recovery as that kind of primary energy demand technology sits really well with these other renewable technologies around it. So if that's okay, I'm going to hold there. Obviously, a number of other different things going on in terms of net zero pilots with other developers. We have a lot of resource online. I won't trouble you with this now, but I will send you some links in the follow-up, and I will also send you a link to our CPDs for trees. So there's to generate your CPD certificate, just click the link, add your basic details. That will give you a CPD certificate for the hour that you've had with me. There is a small feedback element, but that's you don't need to worry about that too much if you don't want to. But for every CPD attendee that we, for every CPD certificate that we generate, we'll donate 25 trees. So just part of the sustainability journey that we're on, and it's a nice way to bring everybody else in to understand our sustainability journey as well. I will hold that there. Sorry, we've run on a little bit, just to see if there's any questions. And as I said, I'm more than happy to stay on afterwards. I know we've got, I think the Galaxy installation guys on as well, so you might have some questions. And also if you want to look at other case studies and things, I've got time for that as well. Thanks, Owen. Thank you. Any questions in the chat, Craig?
Yep, we just had one come in from Owen. Do you want me to read it, or can you see that?
No, as long as you're happy with that, that's fine. I can't see it. Unless, do you want me to answer it?
Yeah, I mean, could you have a look? It just says
let me try and find the
two-part question. In a hotel with showers fed off a secondary circulation domestic hot water system, one, is the wastewater heat recovery still an effective way to save energy? And two, are there any technical implications to be aware of when installing onto a secondary circulation?
Good question. In hotels, assuming that you've got centralised hot water plant, we will probably, you'd be looking, regardless of the wastewater heat recovery product, but probably the pipe hex installed in the service riser, you're going to be looking at system B. So it will be completely isolated from all of your hot water side. We're just on the cold water side. I think I might even have a slide that can cover that. There we go, here's a hotel. So yeah, as an example, so this is a pretty typical blueprint for hotels, student accommodation, where you've got centralised service risers, usually back-to-back shower rooms. The waste from both showers can drop into the wastewater heat recovery unit. This is the old product actually. But then installed as system B. So all we're doing is preheating the feed to the cold side of both shower mixers. So we're completely isolated from the hot water side. So hopefully, I think that answers the question, because we're isolated from the hot water side, so it shouldn't impact it whatsoever. Great stuff, thank you. Good, okay then. Great, well if there's no other questions then, as I say, I will just hang around for a couple of minutes in case anyone's shy and wants to have a chat. But thanks very much everybody. I will follow up with a follow-up email with some links and also with the CPD certificate link as well. So thanks very much. We've recorded the presentation, so I'll also send a recording of the presentation out as well for you. Thanks very much. Thank you.